Hello, welcome to ACE Preparation League. So we will be concluding the today's discussion with the remaining topics. The remaining topics what we have left are, first one is flywheels. First one is flywheels. Second one is governors. Next is balancing. Okay, followed by that is gyroscope, cams, and the last one is vibrations. So all the topics from 1 to 5 are the smaller ones, but whereas vibration is bit lengthier, and there is a definite question expected from vibrations, at least minimum of 2 marks, or it can go up to 4 marks. Okay guys, so let us begin our session, okay, with the flywheels topic. We'll take up the questions from flywheels firstly, right? Yes. So here is the question. A shaper is driven by an electric motor which supplies power at uniform rate of 0.8 kilowatts. So the power is given, power of the motor, that is 0.8 kilowatts, okay, which is coupled or which is the source for the shaper machine. The crank of the shaper runs at 20 rpm. Speed of the crank, that is N crank, is given to us as 20 rpm. 20 rpm, okay. Right. Next is the quick return ratio, QRR. Here this data is given which we generally don't use in the what you call flywheels, but this will be using most of the times in mechanism, but this data is given to us, this is having some significance. Let us try and understand what is that also. Okay, QRR is equal to 2 guys. QRR is 2. A flywheel of moment of inertia 150 kg meter square, I is given to us as 150 kg meter square, okay, controls the speed fluctuation, okay. Assuming the power required during the cutting stroke, the fluctuation of speed of the flywheel as the percentage of mean speed of 200 rpm. Mean speed is given, that is N mean is equal to 200 rpm. Okay guys, so here for this question we are required to determine the fluctuation in speed, okay. Now let us start the problem. So here first is that QRR. First we will be writing QRR. QRR base is basically, it is the cutting time by the return time, okay, or we write it as QRR is equal to time for the cutting stroke, divided by time for the return stroke, which is equal to 2, So here we can say that the return stroke, let us say that cutting time if it is 2 seconds, so return stroke or the time taken for the return stroke will be how many seconds? It is going to be 1 second, okay. So if I assume that T cutting as 2 seconds, so the return time, that is T return, will be equal to 1 second, Now guys, this return time or time taken for the return stroke is basically what? During this return stroke, the energy or there is no work being done by the shaper machine. So when there is no work being done by the shaper machine, what happens, guys? What happens? That energy, whatever is there in the return stroke, is stored by the flywheel. Whatever that energy is there, that is stored by the flywheel. So this time will help us to understand the energy stored in the flywheel. Okay, so energy stored in the flywheel that is equal to, now look here guys, we have the data relating to the motor. So the motor is supplying 8 kilowatts, or the power of the motor is 8 kilowatts. I can write this as it is supplying energy of 800 watts. This 800 watts can be expressed as 800 Newton meter per second. So this motor is supplying 800 joules of energy for a single second. It can be understood this way also, because this motor is going to work continuously as long as the shaper machine is working. Okay, so and again in that you are going to add a additional source which is going to store the energy. Okay, so the energy stored, basically that will happen during the ideal stroke or the return stroke. So energy stored in the flywheel will be equal to whatever the energy we have during the return stroke. Right. So for 1 second, motor is pumping an energy of 800 newtons. So energy stored by the flywheel, will be equal to 800 Newton meter, or basically this will be the excess energy supplied by the flywheel. What actually happens is that if we try to understand the diagram, this is T theta diagram. Okay, so now here if we plot the T theta diagram for the punching operation, the variation will be something like this. For one entire cycle, or 360-degree rotation, there will be a one pulse of torque. Where it will be reaching the peak value and it will be retarding to 0. Okay, so for one entire cycle, this will be the variation of torque. And now the motor is going to pump the constant torque. Whose magnitude is 800. Newton meter for every 1 second. Right. So this will be the motor torque, guys. It will be constant torque. Motor torque will be constant for 1 cycle, and this will be the torque variation for while you are doing the punching operation, which is indicated by the yellow color line. Okay guys, now here we got the energy during the return stroke. This is basically energy supplied by the flywheel when you are performing the whole operation. This is the deficiency in energy or the excess energy supplied by the flywheel, or which basically also represents fluctuation in energy, because here the energy requirement, this is the energy requirement. Okay, this is the energy requirement. This total height or this total yellow color area is the energy required. But what you are supplying at this instant, the energy supplied is this much, a small height. So what happens? This excess requirement in energy is met by the flywheel. That excess in energy is nothing but 800 Newton meter. Guys. Right. So now you can apply the formula directly here, that is delta E is equal to I omega square Cs. Now the data relating to crank of the shaper is given. Okay, let it be. This data we are not going to use, that is 20 rpm. The data which we are going to use is the flywheel data. That is 200 rpm, guys. 200 rpm. So we have here I value, we have here mean speed, we have here delta E also. Only you are left is that you are required to calculate that is CS, coefficient of fluctuation of speed. Okay. So I am putting the values for you. I expect you to respond for the answers. Okay. So delta E is equal to 800 and I will be equal to 150 and omega will be 2 pi into 200 square, 200 by 60 whole square into CS. Okay, into CS. So you will be getting some value of CS. You will be getting some value for CS. Okay guys. So I am waiting for your answer. So please remember, please understand the torque variation while the punching operation is being done and motor torque. Motor is capable of supplying the constant torque. So this height represents the deficiency in the torque. This deficiency is overcome by the flywheel. This deficiency in torque is overcome by the flywheel. Okay guys, can we move to next question? Okay, I am waiting for your answers. Let us go to next question. Yes, another question from the flywheels, that is from the application of punching press. Okay, a constant torque motor of 25 kilowatt. Power of the motor is given to you guys as 0.25 kilowatt. Okay, and this is 250 kilowatts, sorry 250 watts, it is 250 watts. Okay, and this is also equal to 250 Newton meter per second, 250 Newton meter per second. Okay, the motor is capable of pumping 250 joules of work for every single second. Okay, and that work will be stored by the flywheel. That work will be stored by the flywheel. Mass of the moving parts including the flywheel is 125 kgs. Mass of the moving parts including the flywheel is 125 kgs, whereas the radius of gyration is 700 mm, I guess. Yes, it is 700 mm, or that is 0.7 meters. 0.7 meters guys. Okay, one riveting operation, the energy required for punching one hole, the energy required for punching one hole is 1 kilojoules. Energy required for punching one hole is 1 kilojoules. Okay, energy required for punching one hole is 1 kilojoules or 1000 joules. Okay guys, next is speed of the flywheel before the riveting. Speed of the flywheel before the riveting, that means before riveting means that would be the maximum speed. That would be the maximum speed, because after the punching there is going to be retardation. There is going to be retardation, or there will be definitely some drop in speed. What is that drop? I have to calculate. Okay, so this is N maximum guys, which is equal to 240 rpm. 240 rpm. Okay, before riveting. Number of rivets closed per hour. Okay, you are required to calculate in 1 hour how many number of rivets can be punched, right? So number of rivets that can be punched in 1 hour. number of rivets in 1 hour. In 1 hour it is. Okay. That is we are required to calculate. And after riveting and reduction in speed after riveting, by how much RPM there will be a change in the speed after riveting. That is basically delta n we need to calculate. Okay, delta n, that is n maximum minus n minimum is how much it is being asked. Okay, right guys. So now here power data is given and energy for one hole it is given to us. Energy for one hole is given to us. So now here what we can do is, yes, just a minute, yes, and it takes 1 second, yes, operation for punching one hole is taking 1 second guys. The time taken for punching the hole is 1 second. Okay, so first is that we need to draw the torque diagram or torque variation. Okay, torque variation diagram. That is, this is theta, or you can say time also, or time also. Okay, and here it will be torque. Okay, there will be torque here. Now guys, here during the punching operation, the torque will be reaching its peak value and it will be decreasing also. This will be the variation of torque. This will be the variation for, this will be the torque variation when the punching operation is being done. Okay, so this is done for 1 second guys. This is done for 1 second, right? And the cycle time is, of course, it is t seconds. I don't know what it is, but it is t seconds. For every 1 second, for every 1 second, 250 joules of energy is being pumped up by the motor for every 1 second. Okay, so here what we can write it as, this area represents the energy for one hole, and the motor is going to supply, this will be the peak torque, this will be the peak torque. Okay, and motor is going to supply an energy of, 250, okay, or we can say 250 Newton meter of torque, not energy I guess, just a minute. Yes, 250 Newton meter of energy is being supplied actually, that is the energy supplied. Okay, so and this is the time taken. Area under this basically represents the energy. Area under this basically represents the energy. So here, yes, 250 is not the torque guys, 250 is not the torque. So here this will be the energy supplied guys, this will be the energy supplied. Okay, so now here for punching, energy for punching one hole, energy for punching one hole is equal to energy supplied by the motor, energy supplied by the motor, or energy supplied by motor. So here for punching one hole, the energy required is 1000 joules. Okay, 1000 joules, that is 1000 joules, right? 1000 joules it is for 1 second, 1000 joules it is for 1 second. Similarly guys, energy supplied by the motor will be, that is 250 joules, and let us say that it is supplied for t seconds. Let us say that it is supplied for t seconds. So what will be here t? T basically represents the cycle time. T here basically represents the cycle time, that is 1000 by 250, 1000 by 250, which is equal to 4 seconds, which is equal to 4 seconds. Okay guys, so time taken for punching one hole is 4 seconds, right? For punching one hole, it is taking 4 seconds. In 1 hour, how many number of holes are being punched? 3600 by 4. Okay, number of holes in 1 hour. Okay, so in 1 hour there will be 3600 seconds by one hole is taking 4 seconds. 1 hour, one hole is taking 4 seconds. So this will be 900 holes can be punched in 1 hour. 900 holes can be punched in 1 hour, right? Okay guys, right. Now what are the options here? 900 holes and 900 holes. That is option A or D has to be the answer. Option A or D has to be the answer. Now guys, here if you see the diagram, the energy supplied for one hole is 1000. Motor is supplying the energy during that particular duration, for it is supplying an energy of 250. That is for 1 second. 250 is the energy supplied by the motor and the requirement is 1000. So this difference, that is 1000 minus 250, will give us the shortfall in the energy. Hole is 100 joules, 1000 joules of energy is required for one hole, but motor is capable of supplying only 250 joules and motor is supplying continuously. And that energy is being stored by the flywheel. And that excess energy is being covered up by the flywheel itself. Right guys? So here, what I can write it as, fluctuation in energy that is equal to E maximum, which is the whole requirement, minus E minimum, which is being supplied by the motor. And the excess will be covered by the flywheel. 1000 minus 250, which is equal to 750 Newton meters is the fluctuation in energy. 750 Newton meters is the fluctuation in energy. Right. Now you can recall the same equation, that is delta E is equal to I omega square CS. Here I guess we are not dealing with CS, we are dealing with change in the speed. So what I can write here is that I can write here I is equal I into omega max square minus omega minimum square divided by 2, right? So delta E will be 750, delta E is 750, and I guess I will be equal to mk square, where m is 125 and k is 0.7, k is 0.7. So I can write it as mk square. Okay, so that is 125 into 0.7 square into omega max. Omega max is what? 2 pi into 240. 2 pi into 240, right, 240 divided by 60 whole square minus 2 pi into the omega minimum, which is you are required to calculate, divided by 60 whole square. Get the value of omega minimum guys from here. Solve this equation and get the value of omega minimum. Okay. So after getting this omega minimum, you can convert this into rotations per minute, that is n minimum. Similarly guys, get the value of delta n, that is n maximum minus n minimum. Okay, n maximum minus n minimum. So I am waiting for your answers guys. Let me just check what you have given the answer for. Okay, I'll keep the problem as it is. So what answer you have given for question number 1? Yes, yes Rushikesh, definitely this PDF will be uploaded in the video description. You can download definitely from that. Yes, good evening Krishna, good evening Debasis, and good evening Rushi also. Right, happy new year to all of you, those who are watching and those who are writing the exams. Okay, I am expecting the answer. So here the answer would be, I guess first one is 1.2. The percentage in fluctuation in speed is 1.2, that is option A is the answer. Option A is the answer for first. Okay, and similarly here the answer would be option A, that is 900 holes and 4.5 rpm. 4.5 rpm. Okay, right. So moving to next question. Yes, anybody, let me just check anybody have responded or not. Okay. Fine. Yes, this is another question actually from dynamic analysis of the crank slider mechanism. This is another question from the dynamic analysis of crank slider mechanism. The engine crank has a length of 50 centimeters. So R is equal to 50 centimeters. Length of the crank is given to us as 50 centimeters. And the connecting rod length is 200 centimeters. Length of the connecting rod is 200 centimeters. When the crank is perpendicular to connecting rod, yes, the angle subtended between crank and connecting rod is 90 degree, and piston effort for that situation, piston effort has been calculated as Fp, that is equal to 100 kilonewtons, and you are required to determine the turning moment, torque. You are required to determine torque. Okay guys, so for this situation, yes, omega crank is also given to us. Omega crank is given to us, that as 100 rpm. But I guess guys, we are not going to use this data. We are not going to use this data to calculate the torque here. If at all power needed, if you want to calculate the instantaneous power, then we'll be using this data. Otherwise, we are interested in only in calculation of turning moment. Okay. So let me just draw the configuration diagram here. Right. There will be a force of 100 newtons and the angle subtended between these two is 90, not the crank with line of stroke. Okay, angle subtended between crank and connecting rod is 90 degrees. So this will be, R is 50 centimeters, this is 50 centimeters. Okay, and this will be 200 centimeters. Right guys, so you can do one thing here. This is angle phi, this is angle phi, and this will be angle theta. This will be angle theta. Anyways, this is 90 degrees. Anyways, this is 90 degrees, or you can write it as, or basically we write it as 180 minus of theta plus phi also. This is combination of 180 minus of theta plus phi also, mathematically. Okay. Now what you can do is, you can resolve these forces at the two joints by using the free body diagram, or else you can directly recall the formula also for this. Okay. So let me just do the resolution very quick. Okay. So this is FP, this is FP. Okay. This is FP, and this is thrust on the connecting rod, or the connecting rod is going to experience thrust here. So this is phi, and let me write this as F C dot R dot. C dot R dot means that is connecting rod. C dot R dot means that is connecting rod. So how these forces are related? FCR cos phi is equal to FP, is equal to FP. So FCR, thrust on connecting rod, is equal to FP by cos phi, FP by cos phi. Now moving to this joint, moving to this joint A, or crank pin. Okay, crank pin. At the crank pin, you will have the thrust along the connecting rod. This will be FCR. Now if you resolve this along the crank, if you resolve this along the crank, what you will be getting? This will be along the crank, and of course the angle subtended between these two is 90 degrees. The angle subtended between these two is 90 degrees. So this FCR directly, it will be a force which is going to cause the rotation of the crank. FCR, that is thrust on the connecting rod, is going to be perpendicular to the crank, and that force will be responsible for the rotation of the crank. Okay. So or else you can use this formula directly, that is torque is equal to Fp into sine of theta plus phi divided by cos phi into R. Here theta plus phi is already 90, this is already 90 degrees. So you can substitute the remaining values. So here Fp is known to us. I guess we need to calculate phi. We need to calculate here phi. Okay. Let me do that for you. So here phi is equal to, or tan phi is equal to, opposite side is 50, opposite side is 50 divided by adjacent side is 200. So I guess this answer is tan inverse of 0.25, which is 14, which is I guess approximately 14. Okay, 14 degrees. Right. Next is, you can substitute here, Fp is 100 kilonewton, and cosine of 14 approximate. Okay, 14 is approximate value, and the radius is 0.5 guys, radius is 0.5. So this value, I guess cos 14 is very close to cos 0, cos 0 is 1, and cos 10 means it is 0.95 something, and cos 14 means 0.89 something. Okay, so this value 100 into 0.5 is 50, 50, and this will be slightly greater than 51. That is what I am guessing. Approximating I am this to 52 kilonewton meter. I am just approximating this to 52 kilonewton meter. It can be a 51.5 or 52 approximation. Okay guys, so either you can memorize or recall the formulas, or you can resolve into the forces, or you can go by resolution of forces. Resolution of forces. Okay. So sometimes a question is coming from the dynamic analysis of the crank slider mechanism. Okay. So if you understand, or if you are resolving the forces thoroughly, then very easy to crack down this problem. No need to memorize also. Already these fundamentals are being recalled in engineering mechanics. We are doing nothing new here. We are not applying a new approach. Okay. So we are recalling the basics of engineering mechanics, that is drawing the free body diagrams and resolving them along the links. Okay. So we will move to Next question, guys. Yes. This is another question from the governors. Okay. Arms of the Porter governor are each 25 centimeters. Both are equal arms. Both are equal arms. So here, as per the observation, you can write equal arms. Equal arms. 25 centimeters long, and both are pivoted to the axis of rotation. Mass of each ball is 5 kg, that is ball mass is 5 kg, guys, and mass of the central sleeve is capital M, that is 30 kgs, that is 30 kgs. Radius of rotation is 15 centimeters, that is R1, guys, 15 centimeters. Similarly, when the sleeve begins to rise and reaches at 20 centimeter at the maximum speed. So this is the radius of rotation when the sleeve begins to rise. When it is reaching to the peak value of speed, okay, then the radius is found to be 20 centimeters, guys. 20 centimeters. The range of speed is that. The range of speed is dash. For this change in radius, you are required to determine change in speed. Okay. So you know this formula very well, that is H is equal to 1 by omega square into mg plus capital Mg plus or minus F into 1 plus K divided by M. Okay. Now here H1, firstly we need to calculate. Okay, let me just draw the configuration diagram. Arm length is, guys, 250 and radius for this situation is 15 centimeters. I guess arm length is 25 it is, sorry, it is not 250, it is 25. It is 25. Okay. So this height will be equal to H1, So H1 is equal to root over 25 square minus 15 square. Okay, 25 is 625 minus 15 square is 225. 625 minus 225 is 400. So 400 under root is 20 centimeters. Okay, so that is 0.2 meters we can write. Now the radius is increasing. Now you are increasing the radius. Let me just change the color, guys. Okay, let me just change the color here. Okay, this radius has been increased to 20 centimeters. Okay, and for the corresponding situation, what is the height I need to calculate? What is the height I need to calculate? That is H2. H2 is equal to root over 25 square minus 20 square, that is 625 minus 400, which is 225, under root is 15. Okay, 15, that is 0.15 meters. 0.15 meters. Now guys, in this situation, what you have is F is not given to you. Arm lengths are equal. Okay, arm lengths are equal. Okay, just a minute, guys. I think here I am supposed to write it as mg plus F, or plus or minus F by 2 I am supposed to write here. okay, plus or minus f by 2 I am supposed to write. So here 1 plus k, k is basically 1 here because both the arms are of equal length, both the arms are of equal length. So k basically it is the angle subtended by the upper arm and the lower arm with the axis of rotation. So when both the arms are equal, obviously these two angles will be same. So k value will be equal to 1. K will be equal to 1 here, right? So now what you can do is, all is that you have to substitute the values. You have to substitute the values here, okay? So h1 is equal to, that is 0.2 by omega 1 square into mg, small mg. What is small mg? That is 5 into 9.81 plus capital mg. Capital mg is 30 into 9.81. friction is ignored, okay, and this k and this term will be cancelled here. Since k is equal to 1, both of these terms are likely to be cancelled. This 2 and this term will be cancelled because k is equal to 1, okay. Now 30 into 9.81 by 2, and this is divided by m, I guess it is, yes, it is m, that is 5 kg, okay, 5 kg. Solve for omega 1 here. Omega 1 will be under root, that is you have to shift all these, that is 5 into, let me just rewrite this, 5 plus 30 into 9.81 divided by 0.2 raised to the power of 0.5, okay, raised to the power of 0.5. That will be omega 1. Similarly guys, omega 2 also can be calculated very easily. It's just that h1 and h2 are changing. So I don't have to trouble myself for omega 2. That is 5 plus 30 into 9.81 divided by 0.15 raised to the power of 0.5. So what will be these two values, guys? What will be these two values? Please solve for it. And you are required to know the range of speed for this, range of speed, okay. So here if you observe the options also, one is 170, large fluctuation, 204.3, large fluctuation. Option D is also stating 214.3, large fluctuation. Option C is saying 27.3. Okay, so what will be the answer? What will be the answer? Yes guys, I am waiting for your response. So I am waiting for your response, guys. Please respond here. Bittu Kumar have answered 51. Yes, thank you Bittu Kumar. Vishnu, yes, 4.7. Okay. Fine guys, I will give you the hint also from the options. You can have a check on that, because I'll tell you why the option C is correct. See here, if this is the fluctuation, there is likely to have large amplitude of vibration, if there is a fluctuation in maximum and minimum speed, even this is also going to cause vibration, okay, and this is also going to cause vibration. This is not going to cause vibration, or this is going to cause the vibration which is in the safe value. So option C has to be the answer. Without solving also you can judge the option. If such a situation comes, without solving the question also you can judge it. It is just that you have to understand, if the range of speed fluctuation is there, then what will be the vibration. Because basically here you are using the governor to control the fluctuation in speed, or you are required to maintain the speed limits above or below the average value, okay. So option C will be the answer here, right. Next, moving to next question. Guys, in the recent paper, I guess in the 2021 paper, there was a question from the governors chapter, and he has asked about the controlling, or basically the stability analysis of the governor was being questioned to you, and that question was a very simple one, okay. So relating to that question, or relating to that concept, we have another question with us. Let us see that and try and understand what is being asked. In the spring controlled governor, the controlling curve is a straight line. Directly it is mentioned. Spring controlled governor will have a controlling curve as a straight line. Okay. Balls are, the ball radius or the balls are 500 mm apart. That is radius of rotation, which is, let us say, R1, 500 mm apart. Okay. When the controlling force is 1800, F1 is equal to 1800. Okay. Next is, and they are 300 mm apart. Radius 2 says for 300 mm distance, or for 300 mm radius, the controlling force is 1000. The controlling force is 1000. To make the governor isochronous, the initial tension must be decreased by dash. Yes. Here, first is that we need to understand the stability curves of the governor for unstable governor, isochronous governor, and stable governor. Once you are thorough with the curves, then this problem can be cracked down very easily. Okay. Let me just draw the curves for you guys. Okay, that is not curves actually, we are drawing the straight lines to be precise. Okay. So we know very well this is the line passing through origin, the F and R. Okay. So here we can write this as F is equal to A times of R. This is A times of R. And this line is having a positive intercept. This will be F is equal to A plus R. And this line is having AR plus B, actually it is AR plus B. Next is the other line is having negative intercept. So I am supposed to write here F is equal to AR minus B. Okay, so this line here you can say at zero radius there is some controlling force present. The controlling force itself is getting activated at the zero radius. How that can happen? That is unstable governor. Just simply we will name it as unstable governor. If you find such situation, directly it is unstable governor. Okay. Next is, this is called as isochronous governor. This is called as isochronous governor. Okay. Whereas here after certain radius we can say after certain radius, we can say that controlling force is active. Of course, this will be stable governor. Stable governor. Okay. Now, what is controlling force? The controlling force is the combination of mass, gravity, or the controlling force is the combination of weight, friction force, okay, and spring force all together in a spring controlled governor. All these combined together will be contributing for the controlling of governor. I repeat once again, the mass of the ball, the mass of the sleeve, and the spring force and the friction, all these together will be doing some contribution to the controlling force. Okay. Just remember the behavior of radius and controlling force diagram. You don't have to relate them mathematically. Okay. Just remember this. This is enough for us to tackle any kind of a problem. Okay. So now going back to this question. Okay, let me just, I guess I forgot to say something here. Now, if you want to bring a unstable governor to isochronous, you are required to remove this y-intercept. That y-intercept is what? Force. That y-intercept is what? Force. And if you want to bring the governor to the stable situation, first is that you can bring that to isochronous, and from isochronous to stable it can be brought. So in short, you are required to decrease this the value of controlling force. The controlling force, how it can be decreased? By decreasing the spring force, because this is we are dealing with what? We are dealing with a spring control governor. So by decreasing the spring force or initial tension in the spring, if that is decreased, then governor will be brought to stable position. Okay. So here we are required to make it as isochronous. We are required to make it as isochronous. So we know this, we can apply simple mathematics here. That is F is equal to, or F1 is equal to AR1 plus B. Okay, that is 1800 is equal to A into 0.5 plus B. That is equation number 1. Okay, and similarly F2 is equal to AR2 plus B, that is 1000 A into 0.3 plus B. Now guys, solve for A and B. It is a simple algebra here. Okay, solve for this. 1800, that is 0.5 A plus B, and 1000 is equal to 0.3 A plus B. This will be minus sign, this will be minus, this will be minus. B and B is cancelled. So here I guess it has to be 4000, or how much it is? 800 it is equal to 0.2 times of A, 0.2 times of A, which is 4000. Which is 4000. A is equal to 4000, that is some constant, Next is guys B I required to calculate. So B is equal to 1800, A is 0.5, A is 4000, A is 4000. So this is, yes, B is equal to 1800 minus A times of 0.5, that is 1800 minus A is how much? A is 4000 into 0.5, which is equal to how much it would be? Minus 200. Okay, minus 200. So we are getting this as, that is equation of the governor, or the controlling force equation is 4000 R minus 200. 4000 R minus 200 is the equation for the controlling force. Of course, this is going to be stable governor, guys. this is going to be stable governor. So if you want to make it isochronous, then what is it? Yes, if you want to make it isochronous, you are required to increase the tension. You are required to increase the initial tension. Okay, to make the governor isochronous, the initial tension must be increased here, not decreased. Initial tension must be increased by 200. Initial tension must be increased by 200. Okay, or else what I can say, other statement what we can add is, here it is saying to make the governor isochronous, initial tension must be decreased by minus 200. Even that is also correct. Even that is also correct. Okay. So here it says F is equal to 4000 R minus 200 minus, you are decreasing by minus 200, which is equal to 4000 R. These two will be cancelled. These two will be cancelled. So here the option is going to be that is D. You have to decrease it by minus 200. In short, you are increasing. Okay guys, we'll break. Yes, Rushikesh Kasat is, yes, I have replied already to your question that PDF will be available in the description. Please once again rewind the video and you will have that answer also once again. Okay, तो आपको PDF definitely मिलेगा क्योंकि ये सेशन आप ही के लिए है. Okay, yes guys, moving to next question. A single cylinder oil engine has a stroke of 38 centimeters and crank rotates at 360 rpm. Okay. The reciprocating parts weigh 670 newtons, revolving part weigh 800 newtons. This is the clear indication that this question is from the topic balancing of masses. Balancing of masses. At crank radius r, okay, a revolving balance weight is introduced. At some radius r, another balancing mass is introduced. Okay, at a radius of, okay, just a minute, here reciprocating parts weigh 670 and rotating parts weigh 800 newtons at crank radius r. Okay, revolving balance weight is introduced at a radius of 15 centimeters. Okay, and to balance the whole of revolving you are required to balance, and one half of the reciprocating, which means 50% of the reciprocating parts are required to be balanced. Okay. Next is the magnitude of balancing weight required is dash. Magnitude of balancing weight required is dash, and the residual unbalanced force on the crankshaft is dash. Okay. So here we are going to discuss about the balancing of masses. Right. So let me just, yes, stroke length. Stroke length is given by 2 times of r, that is 38 centimeters, or r is equal to 19 centimeters or 0.9 meters. Okay, right guys, and next is the cranks rotates at a speed of 360 rpm. So n is equal to 360 rpm. So from here you can get omega value, that is omega is equal to 2 pi into 360 by 60. Approximately this is 37 or 38, in between that, radians per second. Okay, 37 radians per second I am guessing. Okay, so you can reply that. Right, next is the revolving, yes, now rotating parts and reciprocating parts. Mass of the reciprocating parts, m reci, that is 670 by 9.81. Okay, that is equal to 67 or 68 approximately, that is equal to 68 approximately kgs, and m rotating, that is equal to 800, I guess 800 newtons. So 800 newtons divided by 9.81, okay, and next is that this is equal to approximately 81 kgs, okay. Now you are required to balance 50% of reciprocating and 100% of revolving mass by introducing the mass at a radius of 15 centimeters. By introducing the mass at a radius of 15 centimeters. Okay. So here we can write, that is B is the balancing mass. B will be balancing mass and this is introduced at a radius of b, small b, which is equal to 15 centimeters, I guess that is 0.15, that is 0.15. Okay guys, this is equal to balancing mass. Yes, now yes. This will be the crank slider mechanism. This is making an angle theta. This is making an angle theta. Here inertia force will be there, which is the combination of mr omega square cos theta plus mr omega square cos 2 theta by n. We generally ignore the effect of secondary forces. Reason is that n is greater than 1 compared to this. Okay, the secondary forces are having certain magnitude, but it is less significant over primary forces. Okay, so I will be ignoring this part. So I will be getting that directly as mr omega square cos theta, mr omega square cos theta. So which means that there will be an unbalanced force along the line of stroke, which is mr omega square cos theta. Same unbalanced force will be present along the line of force. Because of the presence of this unbalanced force also, we can say that piston will be experiencing, or it will be undergoing translation along the line of stroke. Now we can just minimize the amplitude of unbalanced forces. We can't eliminate that. So that is done by introducing a mass b at a radius of small b. Okay, so this will be having two components, diametrically opposite to that we are placing, diametrically opposite to this point we are placing b. Okay, so this will be once again theta, and this will be bb omega square cos theta, bb omega square cos theta, and this will be bb omega square sin theta guys, bb omega square sin theta. So now the net force present in the x direction will be difference of this and this. Difference of this and this will be the force present in x direction, and this will be the force present in y direction. Now yes, in force in x direction will be equal to, now let me just rewrite here. Whenever we are balancing the mass, that is m into r is equal to, or just a minute guys, yes, b into b, we are only balancing the fraction of reciprocating mass. We are balancing only the fraction of reciprocating mass. So b into b will be equal to c times of m into r. This is basically m reciprocating guys. This is m reciprocating. Okay, into r. R is the stroke length. So here the force along the line of stroke will be, that is mr omega square, or m reciprocating it would be mr omega square minus c times of mr omega square cos theta. This will be the force in x direction, right? Similarly Fy, that is equal to mr omega square, or c times, basically in y direction bb omega square sin theta is present, so it will be c times of mr omega square sin theta guys, sin theta. Resultant force guys, will be combination of these two. Resultant force, that is R is equal to, resultant will be combination of sigma fx and sigma fy square. Now guys, let me just write the data for you. Okay, let me just write the data for you. M reciprocating, mass of the reciprocating parts is equal to 670 newtons, which we have calculated that as, approximated that as 68, I guess. Yes, 68 kg is the value of M. Okay, M is equal to 68 kgs approximately, and the crank radius is 38. Okay, stroke is 38, so radius will be 0.19 meters, and omega is approximately, I guess, that is 37. Omega is 37. Omega is 37 radians per second, and you are required to calculate at which location the magnitude of balancing weight required and the residual unbalanced force on the crankshaft. Okay, that is, we are focusing on the maximum value, I guess. We are focusing on the maximum value, and C is equal to that is 0.5. C is equal to 0.5. Let us take theta is equal to 45 degrees. Take theta is equal to 45 degrees. Okay. So what would be this value? Yes. Okay. Yes, another one what we are required to do is magnitude of balancing weight. That one is pending. Okay, let me just do that also. Okay. This is theta. Okay. Yes. Now B into B is equal to M rotating. Rotating, you are balancing fully, and partially the reciprocating masses are being balanced. Okay, into R. Right. So here B is not known. And small b, that is radius of the balancing mass, which is 0.15, radius of the balancing mass is 0.15, and rotating mass, let us keep that in newtons, because in the question also it is been asked in newtons only. So rotating mass is 800 and reciprocating mass is 670. 0.5 into 670 into radius is, that is crank radius is 0.19. So the value of B will be equal to how much, guys? The value of B will be equal to, that is 1400 and yes, guys, anybody has replied? Okay, 1437 would be the value. 1437.66 is the value. Newtons, weight in newtons. Okay. Similarly, the value of unbalanced force, is R value here is equal to 9,221.3 newtons is the value of unbalanced force. Okay, that is option C is the answer. Option C is the answer. Okay. Next, moving to next question, guys. Yes. Every alternate year there is a question from the gyroscope. Every alternate year or every year there is a question from the gyroscope. One time it has been asked with the shaft carrying a disc. They have asked for the aeroplane, that is dip the nose or raise the nose. That kind of effect was already discussed. And the question, another question which can be expected is, that is pitching motion of the ship especially. Okay. So for the turbine rotor, mass is equal to 20,000 kgs. 20,000 kgs. Mass of the turbine rotor is 20,000 kgs. Radius of gyration, that is k, which is equal to 0.75 meters. Speed is 2000 rpm. Speed is 2000 rpm. Okay. When viewed from the front of the ship. Okay. Direction of view is front. Okay. So I'll be recalling that data once I draw the gyroscopic diagram, gyroscopic couple diagram. The ship pitches harmonically with an amplitude of 10 degrees and time period is 20 seconds. So here theta naught, that is amplitude, is 10 degrees and time period is 20 seconds, guys. Time period is 20 seconds. The turbine rotor is, the turbine is supported in the bearings 5 meters apart. Here some more information is given relating to the arrangement of turbine rotor. Additional data is given. Here you are not directly calculating the gyroscopic couple magnitude. Because of that gyroscopic couple magnitude, who is going to suffer? You are going to analyze that. Okay. So maximum reaction at the front bearing when the front of the ship is rising. Okay. So when you are going to rise the ship, what reactions or what set of reactions will be exerted on that bearing and what will be the cumulative effect of that reaction? I am required to estimate that. Okay. The CG of the rotor may be assumed to be at mid-span between the bearings. Okay. Now guys, let me just draw the arrangement here. Okay. Here is the ship given to us. There is some rotor kind of an arrangement which is at a distance of 5 meters, guys. Okay. Here some rotor is given to you. Right. Now, first is that, yes, here the pitching motion is mentioned. Here the pitching motion is mentioned. So it is simple harmonic. So equation for simple harmonic motion is equal to theta is equal to theta naught times of sine of 2 pi into small t by capital T. Capital T is the time period of the oscillation and t, small t, is the instantaneous time. Small t is the instantaneous time, or at which instant you are required to calculate, that is given by the small t. Okay. So similarly here theta dot, which is the angular velocity of precession, that is equal to theta naught, derivative of sine is cos. Okay. Cos 2 pi t by capital T into 2 pi by capital T, because here we are differentiating with reference to small t, or which we call it as d theta by small t. Small t is the instantaneous time, which instant you are calculating, that time is given by small t. Okay. Now the theta dot value here will be equal to theta naught into, it is, into 2 pi by t, and this we are going to consider the maximum value. So I will be eliminating, or I will be putting this as equal to 1. Okay. This will be 1. So here theta dot will be equal to theta naught. Theta naught is what? That is amplitude. Okay, that is amplitude of 10 degrees. 10 degrees into 2 pi into time period is, guys, time period is 20 seconds. Time period is 20 seconds. Okay, divided by 20 into this 10 is expressed in degrees, so I need to write that in radians. I need to write that in radians. So I have to write here pi by 180, guys, pi by 180. Okay, so this value will be equal to approximately 0.005, I guess, or 0.054, I guess. Okay. Okay, just correct me in case if I am missing some zero. 0.05. Yes. Yes, I am waiting for your response. Please, guys, just help me do this calculation. Help me for this calculation. .054 radians per second. Per second. So precision velocity is been calculated, guys. Precision velocity is been calculated, and we are left with gyroscopic couple magnitude. We'll calculate gyroscopic couple magnitude, and then we'll decide. Then we will decide the direction of gyroscope. So gyroscopic couple is generally given by C is equal to I omega times of into omega p. Okay. So I is how much? Yes, mass is given to us, radius of gyration is given to us. So this is 20,000 into 0.75 square, 20,000 into 0.75 square into omega value, that is omega is 2 pi into 2000 by 60 into 0.054. Okay, that is C value, that is C. I guess this is 21,000 approximately. This is 21,000. Please help me do this calculation, guys. Yes, Rushi will be getting this slides, boss. Will be getting the slides. Don't worry. It will be uploaded in the description link. Okay, worry about the problems or help me answer this. Okay, it is 235 Newton meters. 235 Newton meters. Okay, 235 Newton meters is the gyroscopic couple. Right now, we have to understand how this gyroscopic couple going to exert the reactions on the bearings. Okay, let us do that, guys. Let us do that. Computing gyroscopic couple is much easier. Okay, and here the rotor is given to you. Rotor is placed exactly here. Okay, so because of the rotor there will be a weight, that is mg. Okay, mg. So I am giving you only the hint, I am not going to calculate the reactions. So mg here it is 20,000 20,000 into 9.81. 20,000 into 9.81 is mg. So here there will be mg by 2 and this will be also mg by 2. mg by 2. Okay guys. Now observe here carefully. There is a data given to us. There is some data given to us relating to the velocity of spin. The ship, okay, look here. The turbine rotor has a speed of 2000 rpm clockwise when viewed from the front. When you are viewing from the front, according to right hand screw rule, if you curl the fingers in clockwise, if I curl the fingers in clockwise, the thumb is pointing towards or against the observer. Okay, it is away from the observer. Thumb is pointing away from the observer. So this here my fingers are curling in clockwise and thumb is pointing towards negative x-axis. Okay, negative x-axis. Yes. So this will be the velocity of spin. This will be velocity of spin. This will be velocity of spin, OX. OX. Now this ship is pitching upwards. This ship is pitching upwards, guys. It is pitching upwards. Okay. So about z-axis, okay, the ship is pitching upwards. It will be like this. Okay, about z-axis, this pitch, it is going to move upwards. So this is how the fingers are going to curl. This is how the fingers are going to curl. This ship is pitching upwards, right? So now I am required to place that vector which is going to cause the pitching. Okay, which is going to cause the pitching. This is omega p and this is omega. Okay. Now rotate omega in the direction of omega p by 90 degrees. If you rotate omega in the direction of omega p by 90 degrees, what will happen to this vector? What will happen to this vector? It will be pointing downwards. It will be pointing downwards. This is called as active gyroscope. Active gyroscope. Okay. Opposite to this will be the reactive gyroscope. Okay, opposite to this. Now direction of gyroscope will be decided with the help of right hand. So place the thumb in the direction of arrow. How the fingers are curling? These are curling like this. Right, everybody? The fingers are curling like this. Okay. So I need to place that vector here. Due to this vector, the shaft is likely to rotate like this. I mean, it is likely to come out of the board. One point is going to come out of the board, the other point will be going inside the board. So the reactions complementing this gyroscopic couple. Okay. So due to this couple, here this point is going to come out of the board and this point is going to go inside the board. Okay. So the reactions will be like this. The reactions, okay, let me just change the color here. The reactions will be like this, perpendicular, here mg by 2, and this reaction which is C, or C by L basically I am supposed to write. L is the distance between the bearings, this is L, C by L in the forward direction or pointing towards the observer, and C by L pointing towards the board, out of the board and away from the board. Resultant reaction will be root over mg by 2 plus mg by 2 whole square plus C by L whole square. Resultant reaction will be this value, guys. Very, very important problem. Okay, slightly deviated from whatever you had the previous gate questions. Same concept was there with the shaft carrying a single disc. Okay, there we were discussing only shaft with a rotor, but now we are doing the analysis. Okay, when you are taking this within the aerospace or naval application. Okay, when you are considering the same arrangement in the aerospace or naval applications. So I will give you the concept, guys, but I am expecting you guys to solve and get the numbers for me. Okay, so here resultant reaction that is equal to root over mg by 2 whole square plus C by L, that is gyroscopic couple, divided by L whole square. You will be getting some value for reaction. All the values are given. I have calculated mg, okay, and gyroscopic couple is also calculated. This length is 5 meters, guys. This length is 5 meters. Okay, so substitute everything and you will be getting the answer for the resultant reaction. You will see the reaction, one reaction in the XY plane and one reaction in XZ plane. Okay, you will see the reactions in two different planes. Previously we were seeing the reactions in one single plane. One of the reactions will be complementing each other. Okay, right. Let us just move to next question, guys. I am leaving this problem or this calculation for you as an exercise, so please do it. Please watch this problem carefully. Please watch this problem very carefully. Very, very important. Okay. Yes. Another question. A helicopter propeller rotates in counterclockwise direction when viewed from the top about the vertical axis. Okay. Helicopter propeller is given to us. Okay, this is helicopter. There is a propeller. Okay, there is a propeller. Okay, about the top, when viewed from the top, when the helicopter takes right turn, okay, in the horizontal plane, the effect of gyroscope is dash. See, guys, here the propeller is rotating. Okay, so now we'll break now. Guys, this is a theoretical question, so I guess some of you have done it. I'm waiting for response. Okay. Those who have not done it, let me do it for them also. Okay. Right. Here, helicopter propeller rotates in counterclockwise direction. When viewed from the top, when you are viewing from the top, it is rotating in counterclockwise. When you view from the down, that direction will be reversed, that is in clockwise sense. That will be in clockwise sense. So anyways, let us say that it is rotating in clockwise sense when we are viewing from the down. Okay, we are viewing from the down. From the top, it will be anti-clockwise, right? When the helicopter takes right turn, this helicopter is going to turn right or left, whatever it is. The axis, okay, so axis of spin will be this for the fan, this will be the spin axis. And about the same axis, the helicopter is going to turn either left or right, whatever it is. The turning axis, the precession axis and the spin axis are parallel to each other. The spin axis and the precession axis are parallel to each other. So gyroscopic couple will be C will be equal to I omega omega p. This omega and omega p is cross product. So if the two vectors are parallel, then their cross product will be 0. Okay. So omega is also along j cap, that is j axis or y axis, and omega p is also along j. So j cross j will be definitely 0, guys, will be definitely 0. Same kind of a phenomena you will observe in the ship when it is executing rolling motion. Okay. So that is option A is the answer, no effect. Option A is the answer, no effect. Okay. Right. Let me just check somebody has responded or not. Yes, Pushpak Ambilkar, no effect. Yes, correct, Pushpak, correct. Okay. Right. We'll move to next question. Okay, please guys, other guys, I also expect you to respond. Okay. Don't worry about your answers, whether it is correct or not. Right. Displacement of a follower cam in a printing machine is represented by an expression x is equal to 10 theta plus 20 theta square plus 1500 theta cube, where theta is the angle of rotation of cam, jerk is given by the system at any position is dash. Okay. Right guys, we have been doing or we have been developing the cam profile for different stages, for different types of motion. In that we have expressed that y or displacement of the cam as a function of theta, where theta is the angular displacement of the cam, y is the displacement of the follower, okay, in uniform circular motion, in uniform velocity, in cycloidal motion, in simple harmonic motion. Every single time we have expressed that displacement of the follower is mathematical function of angular displacement of cam, guys, of cam. This we have done already. This is the equation given for a random profile. All is that you have to perform mathematics. Simple differentiation. You can crack the problem very easily. Okay. So yesterday also somebody was questioning me that, sir, day before yesterday, I guess, on Friday, that sir, that the problems from velocity or acceleration analysis will be having so much lengthy. Yes, of course. If that is if there is a lengthy problem over there, then that lengthy problem is balanced by simple problems in the other section. That has happened in the year 2021 also. You can check with the mechanics question where we had Lagrange equation, 2 degree of freedom question, 2 degree of freedom problem was there. You can have a check on that. That was a very lengthy problem. Okay, that happens. At least 2 to 3 or 3 to 4 or 5 steps will be there. Okay, so that question also can be expected. Don't take it lightly, because acceleration analysis is gradually getting added in the GATE syllabus. Okay, and that too for the configurations where we are using simple trigonometric ratios and getting all the possible angles, not like what you have in the textbook. Don't refer that. Don't refer that at all. It is completely waste of time. Okay, when you are solving the acceleration and velocity analysis, the one which are there in the GATE examination and one which are there in the test series, only refer those. If you are referring the textbook, definitely it is waste of time, because already you will be struggling to calculate different angles. So we'll move back to this problem and we'll finish it off very quickly. So x is equal to 10 theta plus 20 theta square plus 1500 theta cube. Okay, now velocity of the follower. This is displacement of the follower. X is basically displacement of the follower. So v is equal to dx by dt. We write it. And now x is the function of theta. So we will be splitting this into another variable, dx by d theta into d theta by dt, which is equal to, that is omega times of dx by d theta, dx by d theta. Right guys? Similarly, acceleration, how do we write? That is dv by dt, dv by dt, right? So what we write here, dv by dt is dv by d theta into d theta by dt. This is equal to, that is omega into dv by d theta is what? dv is what? V is equal to omega times of, this is dv, d by d theta of v. V is this expression, right? V is this expression, that is omega times of dx by d theta. Okay, so if I simplify this, I would be getting omega square, omega is constant, this would be d square x by d theta square, d square x by d theta square. Right, next, rate of change of acceleration is called as jerk, d of a by dt, which is equal to, let me just erase this guys. J is equal to dA by dt, which is equal to dA by d theta into d theta by dt, which is equal to, d theta by dt is omega once again, d by d theta of acceleration, which is this expression, that is omega square into d square x by d theta square, d square x by d theta square. This will be guys, this will be omega cube d cube x by d theta cube. Okay, now do the simple differentiation, What is the equation given to us? That is, yes, here if you differentiate these 3 times, only you will be left with what? You will be left with 1500. That is, if I do the differentiation, dx by d theta, which is equal to 10 plus 120 into 2, that is 240. 240 guys, it is 240 theta. 240 theta plus 1500 into 3 is 4500 theta square. Okay, next is d square x by d theta square, which is equal to 0 plus 240 plus 9000 theta. Next, if I differentiate this for 3rd time, this will be d cube theta by d d cube x by d theta cube, which is equal to 9000 guys, 9000. Okay. Now the jerk will be equal to 9000 times of omega cube, 9000 times of omega cube guys. This will be the jerk. This will be the jerk. So in the camps generally you will have a very simple problems, not the twisted ones. Simple mathematics, you can crack the problem very easily. So that is option B is the answer here. Option B is the answer here. Okay, option B is the answer. Let me just magnify this for you. Okay, right. So please remember these mathematical relations when we are expressing this into differential form. Okay, and this is the differentiation. Okay guys, let us move to next problem. Yes. Now, for the cam with simple harmonic motion, with simple harmonic rise, the acceleration and velocity at the midpoint of the rise are respectively dash. So guys, we need to recall here the displacement equation in simple harmonic motion, that is y is equal to h by 2 times of 1 minus cos of pi theta by phi. Theta is the instantaneous cam angle, phi is the angle for the forward stroke, complete angle for the forward stroke. Phi is constant, phi is constant. All is that you have to do the differentiation and check at what values of theta in terms of phi you will have velocity at midpoint. What will be the value of velocity and acceleration at the midpoint? Okay, so let us do this. Let us do this. This will be velocity of the follower dy by dt, that is equal to h by 2 times of derivative of cos is minus sine 0 minus of minus sine pi theta by phi into pi by phi into d theta by dt, which is equal to omega guys, which is equal to omega. This value will be maximum where, sine will be maximum where, when you will convert this ratio into pi by 2. When you will convert this ratio into pi by 2, that is at a location when the cam angle theta is equal to phi by 2. At this location you will have maximum velocity. At this location will be maximum velocity, right? You can try with differentiation, or else without differentiation also we can prove it, that velocity v will be maximum when dv by dt is equal to 0, right? We can also prove with that also. Okay, so acceleration that is equal to dv by dt. Okay, dv by dt. Let me just write down so that there is correct alignment. Acceleration is equal to dv by dt, that is differentiation is h by 2 into pi by phi into omega, derivative of sine is minus cos pi theta by phi. Okay, derivative of sine is minus cos pi theta by phi a. Sorry, derivative of sine is cos actually, integration is minus cos, integration is minus cos. Okay, so you have to be careful here. So this will be at theta is equal to phi by 2, this cosine value, or this will be reduced to 0. Because of that, acceleration will be 0. Acceleration will be 0. So acceleration will be maximum at the beginning of the forward stroke and at the end of the forward stroke. Acceleration will be maximum at the beginning and the end of the forward stroke. So here velocity will be maximum at the midpoint and acceleration will be 0. So that is 0 acceleration and maximum velocity at the midpoint. That is option A. That is option A. Okay. So this was a question from the CAM. Let us go to another part. Yes. So now we'll be discussing the questions on the vibrations, guys. We'll be discussing the questions from the vibrations. Okay. A slender bar of mass m and length L is pivoted at L by 3 from one end and constrained to rotate in horizontal plane with the help of springs as shown. What will be the frequency of vibration in radian per second? Okay, so guys, here the arrangement is given to us, and the point of rotation, let us say this is O. About this point the rod is undergoing rotation. So we know that clearly the mass moment of inertia of the rod about the center point is ml square by 12, is ml square by 12. Now if you are shifting this to at a distance of, this is L by 3, guys, this is L by 3, L by 3 it is written here, L is pivoted at L by 3, the length is pivoted at L by 3 from one end, yes, this is L by 3, guys. Okay, so you are shifting, this is located at L by 2, this moment of inertia is located at L by 2. Now if you are shifting this to L by 3 distance, the moment of inertia will increase, the moment of inertia will increase. This will be L by 3, guys, this will be L by 3. So this will be L by 2 minus L by 3, this will be also still L by 2. Okay, L by 2 minus this will be L by 3, which is L by 6, which is L by 6. Okay, 1 by 2 minus 1 by 3 is 1 by 6. Now if you are shifting to this point O, I about O is equal to ml square by 12 plus ml square by, sorry, this will be m into L by 6 whole square. So 1 by 12 plus 1 by 36 it is, which is, I guess it is ml square by 9, right, ml square by 9. Okay. Now we need to draw the displaced position for this, and after once the displaced position is drawn, then we need to take the moments. Okay, we need to take the moments. So this is the initial position of the slender bar, and after once it is displaced, let us say that this is having larger weight, so it is going to go down and this will be moving upwards. Let us take this as the displaced position. Okay, and here this length from the point O is 2L by 3. So this length or this displacement in the spring will be 2L by 3 times of sine theta, or this angular displacement is so small that is sine theta is equal to theta also, we can say 2 by 3 times of L times of theta. Okay. Next, the other spring which is attached here will be experiencing tension. Okay, and the displacement of this spring will be L by 3 times of sine theta, L by 3 times of sine theta. This displacement will be L by 3 times of sine theta, or which is also equal to L by 3 times of theta. Okay, L by 3 times of theta, guys, right. So the displacements are known. Now look here, this spring, the displacement is in negative y direction, so the spring force is going to act in the positive y direction according to Hooke's law. Here we have written that is spring force is proportional to minus x, right or wrong? Okay, spring force is proportional to minus x, so force will be in the opposite direction of the displacement. Okay, so here let me just write this force as Fs1. Okay, and here the spring is getting displaced. The spring is getting displaced in positive y. So the spring force is going to act in negative y. Let me write this as Fs2. And the rod is rotated in about point O in clockwise sense. So inertial torque will be in opposite sense, that is I theta double dot. Now one thing, remember that the inertial force or inertial torque and this spring S1, that is Fs1 and Fs2, these are restoring elements. The inertial torque, the damping force and the restoring force all will be in same sense, always. In most of the problem you will find the restoring force, the inertial force and the damping force in the same sense. Okay, that will be happening guys most of the times. So please be careful here. Right. So if I take the moments about O, that is equal to 0, that is I theta double dot plus Fs1, that is spring force Fs1 into 2L by 3 is the perpendicular distance from O. 2L by 3 is the perpendicular distance. Similarly, plus Fs2 into L by 3 is equal to 0. Right. Now we know very well what is I theta double dot, that is ml square theta double dot by 9. Fs1 is, the spring here is having the stiffness of I guess it is k by 2, right, and this displacement is 2 by 3 times of L. The displacement of this spring is 2 by 3 times of L. So this I can write it as spring force is spring stiffness is k by 2. Okay. The displacement of the spring is 2L by 3 times of theta. Okay, and perpendicular distance is 2L by 3 times 2L by 3. Similarly, Fs2, what is the stiffness? 2K. 2K is the stiffness. And displacement is L by 3 times of theta guys, L by 3 times of theta into L by 3 is equal to 0. So here 3 and 9 cancelled. Okay, this is 2 and 2 is cancelled, right? L square is, of course, it is going to be cancelled here. So the equations we are left with is m theta double dot plus this is 2k and this is another 2k plus 2k theta is equal to 0. So theta is equal to 4k by m, theta double dot plus 4k by m times of theta is equal to 0. So omega n will be directly equal to root over 4k by m, which is equal to 2 into root over k by m, 2 into root over k by m. Okay, that is option B is the answer. Option B is the answer here. Okay, option B is the answer, right? Yes, Rushi. Okay, here Pushpak Ambikar, no effect. Okay, nobody has commented so far. Okay, moving to next question guys, Okay, let me just minimize this for you. Okay, please watch this, please watch the free body diagram once again. Okay, we'll go to next question. Yes, natural frequency radians per second of a system shown in figure below is dash. Now springs are fixed at an angle, springs are held at an angle and the displacement is horizontal, guys. So here very simple logic I will give it to you. So if you are converting this spring into or if you are making the spring horizontal like this, okay, if you are making the spring horizontal like this, then the stiffness, let us say if this is K is the stiffness and this is the K is the stiffness, in that case when you are making it horizontal, this will be K cos square, let us say this is some angle theta, K cos square theta, and this will be K cos square theta. Okay, directly you can write it as K cos square theta if you are resolving or if you are moving the spring along the displacement, So here what will be the answer? That is K equivalent is equal to 2 times of K cos square theta, that is 2 into K into cos square theta is what? Cos square 45, 2 into cos square 45, which is equal to, that is equal to 2 into cos square 45 is 1 by root 2, 1 by root 2 square is 1 by 2, so this will be K. So omega n, natural frequency omega n will be equal to directly root over K by m. Root over K by m will be the value of omega n. That is option A is the answer. Option A is the answer, guys. Okay, option A is the answer. Right, guys. Okay, fine. Let us move to next question. Yes. A mass of 10 kg is kept on 2 slabs. A mass of 10 kg is kept on 2 slabs. So 10 kg is kept on 2 slabs of isolators placed one over another. Okay. One of the isolators is rubber having the stiffness of 3 kilonewton per meter and damping effect or damping coefficient of 100 newton second per meter, while the other isolator is felt with stiffness 12 kilonewton per meter and damping coefficient of 300 newton second per meter. If the system is in motion on the vertical direction, the damping constant of the system is dash. Okay, guys, please try and understand here. Mass is given to you. On that you have kept an isolator which is the combination of mass and damper. Underneath that another isolator is present with a different combination, So here you can say this spring, these two springs are in series combination. Let us say this is K1, this is K2. Okay, so equivalent stiffness for this, it will be given by K1 K2 by K1 plus K2. Okay, stiffness K1 K2 is directly given to you, guys. Similarly, this is C1 and C2, and for this situation you can also get the equivalent damping coefficient when they are in series. That is CE is equal to C1 C2 by C1 plus C2. Okay, so mass here it is given to us directly as 10 kgs. Mass is given to us directly as 10 kgs. Okay, here the system 1 is having the isolator. Yes, here the stiffness is 3 kilonewton per meter and the damping coefficient is 100 newton second per meter, guys, and K2 is 12 kilonewton per meter, and similarly C2 is 300 newton second per meter, guys. So you will be getting the equivalent stiffness by substituting all these values. Now what is that you are required to do? Zeta you are required to determine. Zeta is equal to C equivalent by 2 into M into KE equivalent. Substitute all these values, guys. So I guess your answer here must be 0.24. Okay, 0.24, that is option B will be the answer here. Very simple question guys, it is a formula based. Springs and dampers are in series arrangement, and for that you are required to calculate damping coefficient. Okay, right, moving to next question. Yes, now this is another question based on shaft and rotor system. A shaft is carrying a rotor at the midspan. Okay, a shaft is carrying rotor at the midspan. Has a critical speed. Critical speed means the speed at which the shaft is beginning to whirl, okay, or it is undergoing violent displacement. It is going to experience the violent displacement, because of which it is going to undergo failure. Okay, so which is also natural frequency guys, we also call that as natural frequency. And critical speed, if the diameter of the shaft is increased by 25% and distance is between the bearings is reduced by 25%, critical speed will be dash. So we know very well that is omega n is the function of stiffness and mass. Okay, so stiffness of the beam is given by the combination of EI by L cube. Stiffness of the beam is given by EI by L cube times of m, right. When we calculate that deflection, omega n is equal to root over G by delta also we write, correct. So in that we will be getting something as EI by L cube times of m, right. So from here critical speed NCR is directly proportional to diameter power 4, that is I, divided by length, cube of length raised to the power of 0.5. Now all is that you have to rewrite this mathematical relationship and solve for the problem, right. N1 by N2 is equal to D1 by D2 whole power 4 raised to the power of 0.5 into L2 by L1 cube raised to the power of 0.5. Okay, everything is given to you. D2 is 1.25 times of D1. Okay, and L1 is, sorry, not L1, L2 it is 0.75 times of L1. Substitute everything, substitute all these values, you will be getting the answer as 25 by 6 root 3. You will be getting the answer as 25 by 6 root 3 guys. Okay, simple relationship. Okay, parameter based study it is, right. Okay, moving to next question. Yes. Yeah, there was a question from the buoyancy force, I guess in the year 2020 or 19. Okay, so here you are giving the displacement to this cylinder. Actually the cylinder has reached to the equilibrium position, and now you are disturbing by giving the displacement x. A cylinder of diameter d, mass m floats vertically in the liquid. Okay, this is the equilibrium position of the cylinder guys. Okay, vertically floats vertically in the liquid of mass density 500 kg per meter cube. 500 kg per meter cube is the density. Okay, rho, that is 500 kg per meter cube as shown in the figure. It is depressed slightly and released. Natural frequency of vibration is dash. So when you are depressing it, inertia force, that is mx double dot, will be acting like this, and buoyancy force or FB will be also acting in the same direction. Okay, for this we are required to write the equation. So capital M is the mass of this cylinder, x double dot plus FB is equal to 0. FB is equal to 0. So mx double dot plus FB is what? FB is density into area into displaced fluid. Whatever the displaced liquid will be there will be equal to the volume of this solid object also. Okay, so rho into area into x is the displacement into g. Okay, acceleration due to gravity also has to be added, is equal to 0, right guys? So here we can write x double dot plus rho times of area into g by m into x is equal to 0. This will give you omega n square. Okay, rho is given to us guys, and the area can be calculated, that is area will be equal to pi by 4 times of d square, into g by m. All the values are given and you can get the omega value very easily. You will be getting the omega value very easily. I guess that is approximately, for this it must be 6, yes, it is omega n will be 6.8 or 6.3 radians per second guys, 6.3 radians per second. Okay, so here the restoring force is the buoyancy force, or restoring is done with the help of water. Previously in this previous problem you can see restoring is done with the help of spring, with the help of water, with the help of gravity. All these three are situations, three different situations in the vibrations guys. Okay, yes, this is also another very simple problem guys, you can try for this. Okay, I will just give you the solution very quickly, because this is a point mass given here, so here it is displaced from the initial position like this. Okay, so here let us say this is theta, so inertial torque will be in opposite sense, that is I theta double dot, and the spring force, even that also will be in opposite sense, that is Fs. Okay, and the damping force is also going to resist the relative motion, so opposite to the direction of displacement the damping force is going to act Fd. Okay guys, so if I take the moments about O, moments about O is equal to 0, I theta double dot plus k into the displacement of this is how much? The displacement of the spring and damper is how much? This displacement is how much? It is A times of theta for the spring, and for the damper it will be A times of theta dot. Okay, so I can write here k into A times of theta into A plus C times of A theta dot will be the damping force, into A is equal to 0. This is spring force and this is damping force. The spring force, damping force, inertia force, all will be in the same sense, right? So now what you can do is here I theta double dot plus, that is C A square theta dot plus K A square theta is equal to 0. So here I will be equal to ml square, theta double dot plus C will be that is damping ratio, damping coefficient is Ca square theta dot plus Ka square theta is equal to 0. This is of the form I equivalent theta double dot plus C equivalent theta dot K equivalent theta is equal to 0, right? Now what you can do is you can get zeta value. Zeta is equal to C equivalent divided by 2 times of I equivalent into K equivalent. Substitute all these values, L, A and C, I and K all are given to you. So if you substitute all these values, you will be getting the answer as option A, that is 400 Newton second per meter. Okay. Moving to next question. So this will be the concluding question for us, right? So basically we have seen so far, we have seen the free vibration and damped vibration, how the equation can be framed and how we can calculate the zeta values. Next one, a 35 kg flow monitoring device, a 35 kg flow monitoring device is placed on the table in a laboratory. Pad is having the stiffness, okay. So here 35 kg flow monitoring device is there, okay. So it is placed on some table, there is some pad here, okay. It is placed on the table, this is some device, this pad is having stiffness and damping ratio. This is having K value as 2 into 10 power 5 Newton per meter, and the damping ratio, that is zeta, not the damping coefficient, zeta is equal to 0.08. 0.08 is placed between the apparatus and the table. It is placed between the apparatus and the table. The table is bolted to the laboratory floor, okay. Table is bolted to the laboratory floor, and the measurement indicate that floor has a steady state amplitude of 5 mm, which means that this base is excited. And it is having a steady state amplitude of 0.5 mm and the frequency is 30 hertz, or forcing frequency or excitation frequency, that is 30 hertz. What is the amplitude of acceleration of the flow monitoring device? So what will be the acceleration of this device, you are required to find out. The floor is having some excitation, certain excitation. So here we need to recall the fundamentals of base excitation, okay. So for that I will give you directly the result, that is Y is the excitation of the device. Let us say Y is the excitation of the device, and base excitation, let us say that it is X, okay. So Y is equal to X times of root over 1 plus 2 times of zeta R whole square divided by root over 1 minus R square whole square plus 2 zeta R whole square. X is given to us as 0.5 mm, zeta is directly given to us, guys, and the stiffness is given as 2 into 10 power 5 and mass is 35 kg. Mass is 35 kg, guys. So omega n is equal to root over K by m, that is root over 2 into 10 power 5 divided by 35. You will be getting some value of omega n, and omega, the forcing frequency or the excitation frequency, is 30 hertz, that is 2 pi into 30 will be omega. So from here we can calculate what is the value of R, that is given by omega n. Once the omega R value is known, okay, and zeta value is also known to you, zeta value is 0.08, 0.08 is zeta value, and X is 0.5 mm. X is 0.5 mm. Okay, so from here you are going to get the value of Y. Substitute X, substitute zeta and omega and R, everything. You will be getting the value of Y from here. Okay, all the values are available. Now after that, you will get the y value. Okay, this will be done. After that, you are required to calculate acceleration. So acceleration here it is given by, acceleration that is given by y double dot is equal to y times of omega square. Okay, omega is already known to us. Y we can calculate from the above equation, and omega is 2 pi into 30 whole square. This will be the acceleration value. Okay. Okay guys, we have discussed the questions on vibrations, flywheels, cam and gyroscope. So these are some of the expected questions. So please go through them once again, and all the very best for your exams. Prepare well.